Williams.
And I'm Billy Thomas.
And welcome to another edition of From the Woods Today.
You know, we've got a really interesting topic, as if not, I say that almost every week.
I know.
But it is there, and we have two topics, but it is really interesting to find out how certain things do. Like, for instance, how does a lightning bug actually glow?
Yeah, so we are so excited today. We've got Dr. Jonathan Larson with us. He's our resident entomologist, and we really appreciate all he does. But he's going to be giving us a presentation talking about, fireflies and lightning bugs and kind of some of that history. And he was just telling us he was at a recent program where, a lot of interest in fireflies and lightning bugs across the state. So we'll look forward to hearing from him. And then I'm going to wrap us up today. I've got a short presentation on or I'm calling it Made in the Shade, right? We approached almost 90 degrees yesterday. So
we needed that shade.
It made me think cool thoughts. So we're going to be talking about shade tolerance, though, and how trees have different shade tolerances and how that impacts their management and growth and all that cool stuff. So it's a lot about how we practice forestry goes into that. So we'll wrap it up with that. But I'm excited to start with Jonathan. If you all have questions for Jonathan or myself later today, you can hit us up via chat if you're with us live. And if you're a podcast listener or a YouTuber, thank you. And you can hit us up via email at forestry.extension@uky.edu, and we can respond via email. But excited to be with you today, Renee, on this nice warm day. Not quite as warm as yesterday, but nice warm day here in Kentucky.
Definitely. So let's go ahead and get started. Jonathan, if you want to come on. Hello, Dr. Larson. Appreciate you being on. Now, I've got to ask you this. You call them lightning bugs. You call them firefly. Well, not you. I do. Fireflies. Are there any difference, or am I speaking out of turn here?
No, actually, that's the very beginning of what I'm going to talk about here today is some linguistics, the differences between regions in the United States and what we call these glowing summer insects, but both are correct.
Okay.
Firefly, I guess I would say, is kind of like the more ivory tower term. So you'll hear me say it a lot, but I grew up saying lightning bug. It's definitely more part of the common parlance, I would say. So both are acceptable. Don't feel bad about saying either of them.
All right, because I was just like, maybe I'm messing this up.
Nope, no messing up.
Sounds good. Looking forward to your presentation.
Yeah, thanks. Appreciate you being here.
So I am here to just talk a little bit about the splendor of fireflies. I think that these are amazing insects. Billy mentioned last night I was in Daviess County, Owensboro, and I was at the Western Kentucky Botanical Garden, and we had an amazing turnout. There were a lot of families that came out to celebrate fireflies, and kids were catching them in jars. I got to do some rotating presentations. The office of the state entomologist was there. There were hot dogs. There were all kinds of signs and face painting. It was a perfect encapsulation of summer. And I really think that's what fireflies kind of are all about for folks, is that it just really reminds them of their childhood. If they're grown up, they're really these symbols of summer. And we'll talk a little bit about that here today. But I wanted to hype them up. I wanted to talk a little bit about what their biology is, what kind of insects they are, and where they fit into the sort of natural world. Also talk about some threats that they face and some ways that we can potentially help the fireflies. And that's kind of how I'll conclude. But I did want to start off with this discussion about what we call them. Renee already alluded to this. This is from a survey from a few years ago. This was a company that was asking people, well, what do you call brown fizzy drinks? And then some people say pop or soda or Coke. What do you call the shoes that you wear when you do athletic activities? And some people call them sneakers, or some people call them tennis shoes. What do you call a semi-truck, an 18-wheeler, or a big rig, or a semi-truck? And they also asked, what do you call the glowing insects of summer? And you can see we do have some distinct regional differences with these two terms, fireflies versus lightning bugs. Lightning bug is much more of a southeastern, kind of midwestern thing, whereas firefly is a little more common as you go further west and you go further north. I found this to be interesting when I first saw it. I thought maybe there would be some more nuance to this. And interestingly, some people have done follow-up surveys and revealed that, yes, it's true, lightning bug is the more common term kind of here in Kentucky and Tennessee and most of Ohio and Indiana. But there's a big ring around us of people that use both words kind of interchangeably. But I will say Kentucky is a strong lightning bug stronghold. This is the term that it seems like most people use when they discuss these particular insects. So when we talk about them in a scientific sense, we refer to them as fireflies. You'll hear me kind of slip between both words because I did grow up in the middle of a bunch of cornfields in Indiana, and we called them lightning bugs. So both terms are acceptable. Neither is problematic. But interestingly, neither of them are completely accurate about the kind of insect that we're talking about. This happens a lot with insects, where we'll use different terms to refer to specific groups of insects, but then those terms kind of bleed out of those groups and get applied to other kinds of insects. So when we talk about fireflies or lightning bugs, there are specific insects that are flies. All flies have two wings. That's what makes them different from other insects. Most winged insects have four wings, which you can see in these two pictures. So fireflies are not truly flies because of this anatomical difference. They are also not bugs. Bugs are types of insects that have needle-like mouth parts that they use to feed on fluids for food. So the true bugs include the seed bugs, the bed bugs, the stink bugs, the aphids, the cicadas, things like that. We use these two terms, though, to talk about flying insects or insects become bugs in a lot of common language just because those terms are kind of interchangeable in most people's minds. But when we're talking about fireflies, we're not talking about flies or bugs at all. We're talking about beetles. So they are a part of the Coleoptera, the beetle order. Beetles are different from other insects because if you look at these two pictures, you can see when they open their wings, the front pair of wings is hardened. It is darker in color usually and very tough. And they use this to cover up the more membranous wings in the back, which they will fold up underneath the front wing covers so that they can be protected. This is a little video showing a lady beetle popping the elytra open, unfolding her wings, and then taking flight. All beetles have these hardened covers in the front. The fireflies and some of their kin, if you've ever held a firefly, something you may have noticed about them is that they feel more fragile than we usually assume a beetle will feel. Most beetles feel very tough and robust and kind of crunchy, just even in your between your fingertips if you smush them. Fireflies, on the other hand, they feel more membranous and they feel kind of leathery, and that includes their front wings. And for that reason, sometimes they're considered a part of a group of beetles called the leatherwings. Leatherwings include these other insects that you see here in the center and on the right. So fireflies are related to click beetles as well as soldier beetles. The click beetles that you see in the middle, they're famous for being able to kind of push their thorax and abdomen together. They make an audible click when they release the potential energy there, and then they can jump in the air because of this. So if you flop them on their back, they will lift themselves up using this clicking action. They look a little different than fireflies. They are harder in appearance and texture. They often kind of look seed-like with these hairs all over their body. They usually have sawtooth-like antennae. They also have these kind of thorns that extend off of each side of the thorax. But click beetles are capable of glowing during part of their life cycle, and that's what makes these two related. They have these small glowing spots on a part of their body, and that is the reason that we link the fireflies and the click beetles. The fireflies, though, are kind of in between the click beetles and these other insects that you see here, soldier beetles. Soldier beetles look almost identical to fireflies. They have the same kind of leathery, softer texture to them, but they are not capable of glowing. Soldier beetles in Kentucky, most people will have associated with them on goldenrod, our state flower. Goldenrod is also very popular with the goldenrod soldier beetle, which you see on the right here. The soldier beetles are pretty harmless. They eat pollen and nectar. They don't really do much besides that, but they aren't capable of glowing. They just look a lot like a firefly. So truly the firefly kind of combines traits of both of these groups to create their own little family, the Lampyridae, or the fireflies. The other thing I'll point out about fireflies and their beetle-like attributes are their life cycles. So they go through complete metamorphosis. Fireflies will lay eggs, and then the eggs will hatch, and out will come a larva. Larval fireflies are pretty unique. They look, I think, very prehistoric. They look kind of like a millipede with 6 legs, some people would say. I say that they look like an armor-plated dinosaur because they kind of have this weird, exaggerated plating that goes over the top of their body. We'll talk more about them here in a moment. But after they live in this stage for about 2 years, they will pupate. And then the pupal form will be hidden. And as they develop in the pupa, they will then emerge as an adult. The adult looks radically different from the larval form. It behaves very differently as well. That's why we call this complete metamorphosis. And then they mate, they lay eggs, and the whole cycle begins anew for that year. When we look at firefly eggs, they are usually kind of this pearly white color, but then what happens is they glow. Firefly glowing is not contained just to the adults. they will glow throughout their entire life cycle. This is not directed glowing in this case. It's just sort of random happenstance glowing. They're not glowing constantly. It'll just turn on every now and then. So you can see on the left, these eggs, they're currently in the off position. But then on the right, those are some glowing firefly eggs that somebody discovered down in some leaf litter. So if you're ever going through the forest and kind of foraging around and it's dusk or night, you may actually see these little specks of light that are glowing in some of the more kind of swampy, wetter areas with lots of leaf litter. They can be in the cracks of tree bark, either fallen trees or standing trees, but you'll see these little pinpricks of light as they start to glow. Larval fireflies come out of these eggs and they live in these kind of damp, boggy areas as well. Interestingly, they are predators when they are larvae. People think of fireflies as these kind of cute, cuddly insects, but they're actually quite voracious when they're larvae. They eat earthworms, they eat snails, they eat slugs, and they do this with their mandibles. If we look on the left, we see that armor plating there again with this particular larva. They have a long, skinny neck that exudes from the thorax, and then this kind of tiny head at the tip. They have the ability to bite things and then pull them closer to them and gobble them up. So they will eat those earthworms or snails or slugs. Renee was asking me before the show how to get rid of snails and slugs in the garden. We have various methods for that it can include diatomaceous earth and beer traps and things. But if she went out and recruited a lot of firefly larvae, she would maybe get those numbers down as well. They are capable of glowing in this stage. The one on the right, this is not an insect shooting a lightning bolt out of its butt. It is a time-lapse photograph of a firefly moving down a twig. And so you can see the glow as it trails behind them. All fireflies have glowing at this stage. That is kind of a requirement to be in this group, is that your immature form will glow. So this is all kind of wrapped up in this 2-year cycle where they're living in this form, and then they will pupate. The pupa are often found in patches of moss. They can be found in the soil, on tree bark, beneath rocks, and they often will pupate in groups. You can see a cluster of them on the left there. One of the things that I find alarming about their development is they will also glow in the pupal form. The pupal form can't really move, and so it's flashing its butt. And then if something notices that, they could potentially come over and gobble them up. It's like having your own all-you-can-eat buffet sign installed on your rear end. I think it's quite horrifying to think of that. But the pupal form in all insects that do this is always this really interesting mishmash of the adult and larval form. And I think fireflies are very evocative of that. We can see the start of the kind of thorax shield over the head here. We can see the antenna from the top of the head, but the abdomen still looks kind of like the larval form. We see some of that armor plating still sticking out there. It's a really interesting mishmash. They will usually pupate here in Kentucky at the start of May, and then they'll spend the whole month of May in this form, and then they start to appear at the end of May or at the start of June as adults. The adults are, of course, the most familiar form to most people. They are these famous black beetles with kind of red and yellow markings. Many people think of them as cute, especially when they're seen from above, because their thorax shield kind of covers up their head. So they look like they have this kind of unassuming, non-threatening head. But really, if you get underneath there, they have very classic insect appearance. Many people don't find them as cute when they see their big bulging eyes or their little mouths or their antenna, but they are still adorable to me just because they are able to glow. They have this warning coloration to advertise the fact that they are distasteful. If you've ever held a firefly in your bare hands and then you kind of smell your hands afterwards, you will have detected a chemical defense that they can exude. It's specific to them. They pick it up from milkweed plants. So most adult fireflies do not eat as adults, but they will go to milkweed flowers and consume pollen and nectar, and that allows them to pick up chemical defenses. And then when something eats a firefly adult, it tastes very bad. They remember that flavor and this color pattern, and then they avoid eating fireflies after that. Once they're in this stage, they can glow in many cases, but not all adult fireflies are capable of bioluminescence. Some of them never glow. They don't have a lantern. The one on the right there is called the winter firefly. They are present in Kentucky. I actually saw one, I think, this past fall or past winter, last year. Yeah. If you have oak trees, they're sometimes associated with those. People who produce maple syrup, they often complain about them because they'll get in buckets of maple syrup, but they are non-glowing fireflies that are active in the colder months. If they do glow, they tend to be in these three different colors that you see over here. We have yellow, and then kind of a highlighter green, and then this kind of amber orange color. The amber orange color is not very common in this part of the country. We're more familiar with the highlighter green and yellow ones. So we're talking about Photinus species and Photurus species. These are just different genus names for fireflies that we have here in Kentucky. When we talk about bioluminescence, I saw Dr. Crocker on the call as well. She is probably very familiar with some glowing fungi that are out in the landscape. We see glowing jellyfish and all kinds of things in nature. It's not always apparent, I think, what the glowing is for. Sometimes it seems like things just glow because we live on a weird and wild world. Other times they're illuminating the environment to add some sort of attributes to it. But some others use these bioluminescent glows to attract food. The anglerfish is a great example of that. This is a deep sea predator that has a glowing bulb on a horn on its forehead. Things will glow, go towards the glow, and then she'll eat them with her nightmare mouth that you can see there. But when we talk about fireflies, it's a unique situation. They're actually communicating with this glow. So similar to what we do with lighthouses or sort of light signals at harbors or at airports, that's what fireflies are doing with their glowing butts. They're actually talking to one another. In this image, you're seeing a lot of conversations happening all at once. The male fireflies are in the air. They're aerial and flying around and then glowing their signal down into the grass. In the grassy area are females, and the females will signal back from down below. The male will respond to these signals if it's the correct signal that tells him she's a member of his species, and then he'll fly down and then try to commence the mating. There are several different glows that we can see here in Kentucky. Oops, I hit the wrong button. So if you want to go outside and kind of look around and see what you can see, you can identify species using the patterns. These are all Photinus species that are listed here. I brought a little finger flashlight that my daughter has that I thought maybe I could use to demonstrate some of this too. So if you see me up in the corner, we have the Photinus pyralis, which is the flying jay. They kind of make this lazy fish hook as they fly, and then they'll pause and make another one. They go down, kind of down, then up in this swooping motion that when we look at it in long range exposure looks like a jay. There are others that make sort of repeated dots. So marginellus, it goes beep, 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 beep throughout the air. Others make these kind of dash lines. Others make these kind of longer dashes. And some of them go very fast. They make this 6-blink pattern. Pause, 6 blinks really fast, pause, 6 blinks really fast again. This is often presented as like, oh yeah, everybody can go outside and just watch and see all the fireflies. But it's important to point out that this is happening very quickly. There are lots of competing fireflies all at once. They do sort of differentiate throughout the evening into the night. So you might see different species at 6, 7, 8, and 9 p.m. But it's very confusing to our eyes. They're talking to one another, not to us. You can try it in the field, but it's not always as simple as some people try to present it, I don't think. This is a time-lapse video that we took a couple summers ago at the South Farm, the University of Kentucky South Farm here in Fayette County. And hopefully it'll play for you, but we'll just show you kind of over the course of about 3.5 hours what happens in the landscape with fireflies. So you can see some of the flashing dots as they go through, some of the responses from the grass. As it gets darker, we'll start to see some more erratic patterns as well as some longer lines, and things are going well into the darkness. And then eventually they'll kind of dissipate as it enters, I'd say, deeper night. So past 9:30 or 10 o'clock, that's when things start to calm down. But this, I think, is a very evocative of all the different flashes that you may encounter. It was a lot of fun going out and making these kinds of videos over the course of a summer. I have pointed out that there are these species-specific ones, but interestingly, there's one type of firefly that has a female in it that she knows all of the signals. She is sort of a code breaker, and she will signal from the grass at males that are flying. And so he's flying around and he's making his species-specific flash, and then he sees a corresponding flash from the grass, and he's like, oh boy, I can't believe it. I finally get to go on a date. And he kind of flies down to the ground, and then she grabs him and eats him. It's a tough lesson to learn. She absorbs his chemical defenses as she does this, and then he's discarded. But this is, I think, interesting because we talk about it as very species specific, but there is one that seems to have cracked the code on some of the others. The big question that we get with these, I'd say, sort of from a biological perspective, is how do they do this? And this is even how Renee invited me onto the show, was how do they make the glow? I couldn't make 30 minutes out of that, but it is an interesting process. It's one that we're still studying, I will say, in entomology. We don't think that we have fully cracked exactly how it's happening. But the way that we best understand it right now is that if you look at a firefly's abdomen, there is this kind of highlighter yellow looking area, even when it's not glowing. And inside of there is a chamber where they can mix two key ingredients, luciferin and luciferase. One of them is an enzyme that breaks down the other. This is combined with a biological chemical called ATP, as well as oxygen. And this chemical reaction that occurs very quickly in the abdomen creates light, as opposed to fizzing or heating up or anything like that. It produces luminescence. When we look, at the chemical process, it's remarkably efficient. The energy that they're expending is about 90% of it is going to be used to produce straight light, and only 10% is wasted as heat. That's why when you hold a firefly, you don't feel a burning sensation like you do when you touch a light bulb. Our light bulbs waste about 90% of their energy as heat, whereas 10% of that energy is expended on light. That's a traditional light bulb. Some of the newer ones are much more efficient, but it is an interesting sort of comparison between our electrical capabilities and their bioluminescent capabilities. I always enjoy talking about fireflies because they're so interesting to people and people are so passionate about them. Most insects people are willing to kill. I would say fireflies are a part of a unique group of charismatic microfauna that humans are willing to accept. And that has a lot to do with the feelings of summer I alluded to before. People have very fond memories that they associate with fireflies. They're often thought of as the bringers of summer. They start to appear right around the time that school ends, right around the time that people might be going on family vacations, even around the 4th of July. And they seem kind of like natural fireworks to some people. This is true the world over. There's lots of cultural associations with fireflies. In Japan, in particular, there's a long history of poetry and art surrounding fireflies. In their culture, they're often associated with kind of romance, particularly youthful romance, with being young, as well as souls. A lot of the art that I've seen from Japan, the way that I interpret it at least, it's a lot of people with boxes of fireflies and they're letting them go or trying to capture them. And the fireflies are kind of going up towards the sky, which is evocative of the soul leaving the earth and going to the afterlife. In Japan, they have a song. It's called Hotaru no Hikari. Hotaru is what they call fireflies. This song is sung at events where people bid farewell to one another, is my understanding. So graduations and things like that. It's actually sang to the tune of Auld Lang Syne, which I think is also evocative of New Year's and going away and things like that. So culturally, this has a lot of cachet there, where the Fireflies play a lot in their poetry and in their art. That's true here as well. For example, we have artwork and sort of corporate depictions of them. We have the Columbia Fireflies, a minor league baseball team in South Carolina. I don't really like their logo because the insect's on fire, but it is evocative of the name. They're used in things like comic books. So this is Firefly from DC Comics. He's a Batman villain. He really leans into the fire part. He's an arsonist, and he wears a costume that lets him fly, kind of like a firefly. Other people in the US use them for humor's sake. I have said glowing butts a lot. Ogden Nash, I am following his tradition. He was an American humorist, and this is a poem he wrote. The firefly's flame is something for which science has no name. I can think of nothing eerier than flying around with an unidentified glow on a person's posterior. So just talking about the fact that their butts are on fire, and it's kind of weird, and we don't fully understand it. We know a little bit more about it now than when he wrote that poem. But I think one of the major themes that we see in the US with fireflies is nostalgia. Fireflies are very evocative of childhood memories, sometimes of loss, also of innocence, of a time that we have lost where we were different when we were kids, when we believed in the natural world in a different way and believed in the future in a different way sometimes. And we see that in our poetry and our art as well. This is a poem, Firefly, by Jacqueline Woodson. It's almost May, and yesterday I saw a firefly. You don't see them a lot in the city, Sometimes in the park in the near dark, one comes out, you'll hear a little kid shout, lightning bug, firefly. It's almost May, and yesterday I caught a firefly in my hand. First firefly I seen in a long, long time. Make a wish, Miss Edna said. Make a good one. Firefly wishes always come true. So I think that's pretty evocative of childhood, of being a grown up and wondering why something that you sort of recognize as part of your past is missing in a way. I think that's what fireflies represent to a lot of adult Americans in particular. As a result of that, there is a lot of firefly tourism. It's a particularly powerful economic force down in Tennessee. You can go to the Smoky Mountains and join tour groups of firefly enthusiasts, and they will take you out to watch the synchronous firefly emergences, where you will sit down and then over the course of a few minutes, as it gets dark, the fireflies all synchronously emerge. They make these sort of really big flashes with one another, and then it ends relatively quickly. But it is not this exaggerated sort of continual glowing like we have here. It's much more of this blast of light, all these fireflies coming up and making the vision that we see. It's a lot like a drone show, actually, sort of a natural drone show. And people come from all over the world in order to watch this. One of the things that I wanted to touch on as I kind of conclude, people ask frequently about the disappearance of fireflies or if they're going extinct. We don't have enough concrete data for many of the species to verify this. We do have a lot of anecdotal discussion and evidence that there seems to be fewer fireflies in urban and suburban areas. There have been people that have tried to research this. This is from a paper that I've cited down at the bottom, where the International Union for the Conservation of Nature looked at 132 North American firefly species. They found about half of them didn't have enough data to make comparisons, but the ones that they did have data for, 1% are critically endangered and about 8% are endangered. So this does suggest that there are some problems for fireflies out in the landscape, and those problems are kind of multifold. There are things that are overlapping, creating this kind of perfect storm of negativity. One of the big ones, though, is habitat destruction. As I went through the discussion of their life cycle, I pointed out that they like to be in kind of wet, swampy areas. That's also the kind of area that mosquitoes live in. And we've done a lot of mosquito remediation in the United States by destroying their habitat. Unfortunately, that's also destroyed firefly habitat. We also will turn that into farmland in many cases because it will be good soil. That's why you do see some fireflies associated with the edges of farmland. But those are creating issues where they don't have enough places to lay their eggs in order to have them survive. There's also the negative effects of things like herbicides, which kill out a lot of the vegetation that they rely on to sort of fly above and nest down in so that the females can flash up to the males. Some of this habitat is sprayed out or it's overtaken by invasive vegetation, and then we go and try and remediate that. And there can be competing issues there where the firefly habitat is being destroyed. The habitat that is left to them in many cases is along roadsides, and that's not great because if they stray too far from it, then they go kersplat on somebody's windshield or on the grill of their truck, and you get this glowing spot that then dissipates and no more firefly that can contribute to the next generation. One of the big things that I think is hardest to discuss, though, is light pollution. We create a lot of light as a species, way more than fireflies, and at this point, we have created so much light that we're probably drowning them out. As the advent of modern electricity continued to move throughout the country, you can see this sort of developing map from the late 50s to 2025 showing the amount of light pollution in the United States. This is a chart showing how light pollution affects our ability to see the night sky and what you would see in the inner city, in a suburb, all the way out to the dark sky sort of rural areas that you can find. And fireflies, if they're in these urban and suburban areas, they may not be able to see each other's glow because of this light pollution. And unfortunately, this isn't an easy thing to fix. We keep a lot of lights on. We keep a lot of things glowing at night for safety reasons in particular. And unfortunately, that means the fireflies can't talk to each other. This could also be contributing to people not being able to see the fireflies. They may still be there, but you yourself cannot discern their glow because there's so much light pollution in the area. If you want to help the fireflies, we can do things like reduce outdoor lighting. So taking down security lights and things that you may have on your property, or if you need them up, choose motion activated lighting. Instead of something that glows continuously, it only turns on if a person or a wild animal moves underneath it. You can transform parts of your property into landscaping that they can use. So taking out turf grass and putting in things like gamma grass or other taller grasses that they can hide in and use as a spot, maybe a 6 foot by 6 foot area that can become a firefly spot. You can reduce pesticide applications. When you go out and catch fireflies, please release them in a timely fashion. Don't keep them in a jar for a week and then they'll slowly die. Let them go and let them be a part of nature. Live free and in the wild, as the wildcrats would say, and be able to find one another in order to mate. And you can also join things like the Xerces Society, where they'll give you documents on how to do this. I think they'll even give you a sign that you can put in front of your firefly habitat that will say, "These aren't weeds. I'm trying to help the fireflies." And most people are willing to allow for that. I think I went a little over, but Renee, Billy, I'll turn it back over to you.
As always, Dr. Larson, you do such a good job
Yes.
taking these topics that we all know a little bit about, but you really do a deep dive, and I certainly appreciate it. I'm blown away by the number of species that are out there. That's pretty fascinating. I never.
Yeah, there's way more fireflies, I think, than people recognize. There's a lot of diversity there, diversity in the glow and the color of the glow. I see in the comments that there's a question about fireflies glowing in unison. Do the eggs do this as well? The egg glowing is not quite as directed as what we would say with the adults. It's just random chemical reactions, I think, happening inside of them because they have luciferin and luciferase throughout their life. That's my understanding, at least. So no, it's not directed, and I don't believe it's necessarily in unison.
Now, I thought this was interesting because 2 days ago I was on my porch and I saw this. It looked like the top of a pin. It was that big and it looked just like a firefly.
Uh-huh.
Um, is that a baby one or is it just are there not that was it some other bug and I just thought it was?
No, there are very tiny fireflies, and they
Okay.
often don't glow. So I would guess that's what it was.
Yeah, it didn't
The
glow, but I was like, oh, he's a baby.
Yeah, they're really dark black usually with kind of a bright red circle, and
Yeah.
then their antenna look a little more intense than the bigger fireflies as
Mhm.
well. So that would be my guess is it was a firefly, a
Okay.
non-lantern species. Once they get to that stage, they're grown up. There are no baby fireflies with wings. The baby fireflies, they're the little dinosaur-looking fellas with the
Yeah.
long necks.
That
So
was
yeah.
a little creepy. I'm like, I'm letting that crawl on my hand.
Yeah.
Well, thank
Yeah.
you very much.
Yeah, well, no, quick question for you.
Yeah.
I was thinking about all those different species, right? And they're all kind of in the same habitats, or at least a number of them are in the same habitats. And I know with trees, like we have 20 different species of oak trees or more here in Kentucky. And from time to time, they can hybridize. And I was wondering, do we see any of that with fireflies? Are they very kind of strict in their species selection, I guess? Or do
Yes.
we see some kind of a little back and forth?
With insects, this is always a fun question because the truth is I don't know. Like I'm not sure what's happening out there. I'm sure there is the potential for it. Ostensibly, it's not supposed to happen though. The
Right.
communication that they do with the flashes is supposed to prevent this sort of interspecies play. I'm sure there's also some pheromones that come into play, but you never say never with insects. There's always an
Right.
exception to every rule. We see it with the giant silk moths. They'll occasionally hybridize. So there is the potential, but I am not aware of any hybridized fireflies. That would be awesome. I would really love to see that. Just to see, I love the idea of a mutant firefly would be cool, but I am not aware of any of that though.
Okay.
So
All
that
right.
one that would like do any kind of lightning pattern and then kill the kill the males. Does it have a specific male that it kills, or is it just it's just whatever?
It's just
Opportunist.
whatever. Yeah,
Just
it's an opportunist.
now, what does the female have what it's supposed to do a specific lightning pattern?
Yes.
Or
So if I'm remembering correctly, they're a photourus species as
okay.
opposed to photinus.
Mhm.
And so they do have a species themselves. And at some point, yes, they will want to mate. And so they will call their own male down in order to facilitate that. Probably won't eat him, but they will call to the other males, usually the other species, the jays and the dashes that we were talking about, and they'll
Okay.
gobble them up.
Wow. So they could put some pressure on different species, right? They could kind of.
Well, they're not the most common species, so I
Oh,
wouldn't say
okay.
that they're driving any extinctions or
Okay.
anything. But yeah, they're out there. It's just one of those things I think you'd have to do like a PSA for if you were a parent of fireflies. You would be like, you got to be careful on Firefly Tinder. You never know what's happening.
That is so cool. I didn't know there was different. I know I'd seen different, flashes, but I always just thought it was the same firefly, and they just kind of, one time they're deciding to do this way, and the other time they're deciding to do that way. So I
Right.
learned a lot today. Thank you.
Yeah,
Good.
yeah,
Well, thanks
as
for having
always,
me.
Dr. Larson, you do a great job. We really appreciate you taking some time out of your busy schedule, especially after you not getting home till past midnight last night
Oh, that's
out
the
doing a
life of an
program.
extension
But yeah,
pro.
I know,
It's
I
true.
know.
I'm
But
going to be
thank you.
quiet now and listen to you, Billy.
Oh yeah, we're gonna keep it cool. I'm gonna be talking about Made in the Shade. So yeah, thanks again,
Thanks
Dr.
again,
Larson.
Dr. Larson. All right. So our next guest is Billy Thomas. So you're going to
Yeah,
be talking about some keeping it cool, made in the shade kind of tree topic for us.
yeah. So Renee, I have the pleasure of being able to co-teach one of our introductory forestry classes, right?
Mhm, mhm,
And one of the topics that we talk about is basically how trees can grow in different light levels, right? And we
mhm,
talk about that as shade tolerance. So I put together a presentation kind of going over shade tolerance because I think it's really, I mean, once you start thinking about it a little bit more, you'll be like, oh, that makes sense. And
mhm.
we use this so much as we manage our forest. So I thought it'd give a little insight in how we go about basically managing forests and making decisions on which trees to keep, which trees to remove, and all of that. So I'll go ahead and get started with that today.
Looking forward to it.
Right. So, made in the shade, how shade tolerance influences woodlands and their management. This is an important concept when we think about how to care for our woodlands and how to understand our woodlands. So, I'm going to be talking about the whole process of understanding shade tolerance and how it influences our woodlands, not only their composition, but also how we go about managing them. And this is a fundamental part of forestry, especially in this part of the world, is since we have so many different tree species, they're obviously not all the same, and they all have different kind of habitats where they can be more successful. So this is a big part of how we go about managing forests is understanding various tree species shade tolerance. All right. So I want to go over first, what is shade tolerance? And I kind of alluded to that, but I want to really make the case why it's really important that we understand it. And then I'm going to go over some of the more common different tolerances that we have amongst our trees and how we kind of try to make sense of this big continuum of shade tolerance and try to start grouping some trees into different categories. Makes it a little bit easier when we start managing them. Shade tolerance is really important on basically how trees grow and if they will grow, how successful they will be, which also contributes then to the composition of our forests and how those forests change over time through forest succession. And then we'll wrap up with some techniques on that we can do to influence different species that have different shade tolerances. As we use woodland management to kind of manage our forest, we're thinking a lot about shade tolerance, the species we're targeting, and what we're going to do. And then we'll wrap it up if you have some questions on this really fascinating topic. All right, so let's get into it a little more clearly. What is shade tolerance? So, really, it's referring to a tree's ability to thrive in different light conditions. All trees will probably prefer, as much sunlight as they can get, but some trees really need a lot of sunlight to be successful, while others can get by with less. And this can change over time, even amongst individual tree species. But one great example I like to think about is dogwood. Many people are familiar with our flowering dogwood. It's one of our beautiful native small um, understory species that we have here in Kentucky. It's often planted in yards, but dogwood itself can reach maximum photosynthesis at just 33% sunlight. So, even if it's fully in the sun, it's not able to take advantage of all of that, right? It basically caps out at about 33% full sunlight. So, that is a pretty interesting fact to think about. So other trees have different kind of tolerances as well, but just understand that trees need light, obviously, but how much light they need to be successful varies by tree species, and it can also vary by stage of the tree's lives as well. So we try to make sense of all of this shade tolerance by grouping trees into categories where they have some shared similarities. And the first one is kind of shade tolerant trees. And then we're talking about trees that can grow pretty well with very limited light. And the dogwood's an example of one that can grow with limited light. And then we think about shade intermediate trees. And these are trees that grow in kind of a medium amount of light. And again, this is a spectrum, right? So we have trees that can kind of be on one edge of the spectrum all the way to the other edge, and we can still call those all shade intermediate trees. They will do well, obviously, in full sunlight, but they can get out competed by some other trees that are really shade intolerant. And these are trees that grow really in bright sunlight. They need full sunlight to be successful and thrive. And if there are conditions that limit that amount of sunlight, it's going to limit their success. So this is how we try to make sense of this shade tolerance concept. So we group trees into these various groupings: shade tolerant, shade intermediate, and shade intolerant. And again, this is a lot about how we kind of treat these trees when we're trying to manage our woodlands to achieve whatever objectives we might. So why is shade tolerance important? Well, first, it helps us understand how trees can respond to different conditions. And forestry is a lot about manipulating the conditions that trees are growing in. Which trees do we remove? Which trees do we retain? That's going to have big influences on the amount of sunlight that reaches the ground and reaches those trees. So understanding this shade tolerance concept with individual trees is really critical to make sure that we understand how to manage our forest. So if we're going to implement a practice, we want to know which trees are likely to respond to those changing light levels. So that's an important concept. Because it gives us some insight into how trees grow, and not only grow, but how they survive. So trees may be able to get established in low light levels, but if they don't receive adequate sunlight, they are not going to be survivors. So that's an important thing. And so if certain trees are able to make it and live, that's going to impact the composition of that forest. So understanding shade tolerance can also help us understand the composition of our forests that are out there. And then the concept of forest succession, how forests change over time, is really heavily related to shade tolerance. So let's think a little bit about shade tolerance's impact on tree growth and survival. So one way we can think about is by understanding the shade tolerance, we can really select appropriate species, which can be really important. Now, again, we mentioned you have over 100 native species here in Kentucky, but knowing which trees can grow in various light levels is an important part of that. So it allows us to kind of select the appropriate trees for specific areas and specific objectives. And sometimes that may include planting trees. And we always think about the right tree in the right place. And that means we're trying to match the tree with its environment. We don't want to put a tree in an environment that is not going to be successful. So we really want to be thoughtful. It's a lot of effort and energy to plant trees. And if we're going to do it, we want to make sure that we are successful in doing it. It also influences the forest composition and health, right? As Because shade tolerance influences the trees that are going to grow and be established, that's going to impact the kind of the biodiversity of that site, the overall health of that site. So it's an important thing in understanding that. So we want a mix of species typically, right? We feel like our forests are going to be more resilient and able to respond better to disturbances if we have a good mix of shade tolerances out there. And that's a great thing about Kentucky's woodlands. With very diverse woodlands, we have species that can respond as conditions change. And that way we're not going to be left with some gaps in that forest. There's going to be trees that are going to want to kind of occupy those gaps, and it will be impacted by how big those gaps are to some extent. So let's talk a little bit more about shade tolerance, tree growth, and survival. So natural regeneration is really the thing that we rely most on in forestry here in Kentucky. And again, that's the ideal that these trees can grow more or less on their own. And I did asterisk the human intervention because it's hard to remove humans from this whole chain of events. But generally what we're talking about though is us not having to plant these trees. We're relying on either the sprouts that come up after trees are harvested, or seeds that are in the seed bank to kind of occupy that site over time. And we do know that our shade tolerant species will regenerate in the shaded understory, which is an important thing. And when we think about our shade intolerant species, those that really are intolerant of it, we know that we're going to have to create bigger gaps for them. These gaps are going to have to provide enough sunlight so that they can be successful. And this allows us to implement practices on the forest to achieve landowners' objectives, right? So we can use these ideals of which trees need the amount of sunlight that they need, and then we can kind of set those conditions so that they can be successful. All trees need light, water, and nutrients to be successful, and we have limited ability to influence the water and nutrients that trees can receive. But what we can do is we can influence how much light trees receive, and we do that largely by manipulating the other trees in that environment. By manipulating those trees, we can allocate different amounts of light to different species. So this understanding of which trees do better with different light levels is really important concept for us, right? And again, it gets back to the ideal of knowing that these trees in these different categories of shade tolerance are going to need various light conditions to be successful. So when we're managing forests, we're thinking about what that light's going to look like over time and which trees are likely to be successful in that. We really only can manage this light. So by thinning some trees and retaining others, we use that to manipulate how much light is getting in there. Like I said, we can't really water our woodlands or forests out there, and we can't afford to put fertilizer on them, but we can get in and we can manage which trees are getting the sunlight. And that's really one of our most effective tools to manipulating our forests. All right, so let's talk a little bit about shade tolerance and forest succession. Again, forest succession is that orderly change of forest over time and the lack of disturbance. So this allows us to understand which trees are going to be successful in the long term, right? And that's an important consideration when we're managing species that can live hundreds of years. By understanding how that shade tolerance plays with forest succession, we can set that forest up for future success, right? And again, shade tolerance determines just which species will dominate at different stages. And we'll talk about the different stages here in a moment, but just think about the light that's in the woods. When you've been walking through woods, there's areas where it's been really kind of dark and shady. Not only is it cooler, but the species composition is likely to be different from areas that are open and have a lot more sunlight in them. So all of this has a big impact on that forest overall, right? So we know that our early stages are going to be dominated by shade intolerant, and that's typically because we have a lot of sunlight available for them. And then as time goes on, we expect more and more shade tolerant species to start dominating the canopy, and that's going to limit some of those intermediate and shade intolerant species from getting established, which has a big impact on that forest succession over time. So speaking of kind of changing over time, if you could imagine a forest that was had some type of disturbance, and that could have been a wildfire, really heavy wildfire that really damaged the canopy trees. It could be a timber harvest or a clear cut that removed all of the canopy. So you've got an area now that's really receiving full sunlight, and that means that the trees that are basically intolerant of shade are going to have a leg up. They're going to be able to get established often and be very successful in that. The picture in the upper right-hand corner there is of American sycamore. This is a shade intolerant species. It can vary over time, but you'll see it getting established in some bright sunny areas, especially after disturbance around water, maybe flooding or other areas as well. But what this pioneer stage is doing is it's really setting up that forest for that next stage of succession. So often these pioneer species will be shorter lived, and they will basically improve the soil for that next grouping of species that are going to establish on that site. The next stage we think about is an intermediate stage, right? So that's we're starting to get that transition from those pioneer species to those species that are going to be there a little bit longer, and that's going to change that kind of the amount of shade that's in there on that ground. And again, over time, this is going to kind of gradually get more and more shaded, and we'll end up later in kind of this climax stage. And without any disturbances or, a kind of a stable setting. We expect our forest to kind of change, at least here in Kentucky over time, maybe to that more maple and beech over time, certainly in some areas that are really shade tolerant species and can do well in these really limited light uh, regime. So when we get this thick canopy up there and it's not letting a lot of light down, it's really almost impossible for some of these shade intolerant and shade intermediate species to even get established. So I hope that helps you understand how the shade tolerance really plays in to what trees are on a site at any given time. Okay, so let's talk a little bit about forest successions and understanding these forests and how they change. So again, we think long term when we think forestry, right? We're not really in and out real fast. This is something that we're going to be doing over a long period of time. So we want to be thoughtful in our work, and knowing the shade tolerance is absolutely critical, right? Because then we can make some projections on what's likely to happen. So if we're trying to manage forests for landowner objectives, we're going to make some decisions on which trees to remove. By understanding all of this forest succession and shade tolerance just interplay, it allows us to make these appropriate decisions. And really what we're doing is managing these various disturbances, right? That's what we mimic often in forestry, is different types of disturbances, and their intensity can vary. The extent of them can vary as well. But what we want to do is we want to take our knowledge of how these forests are likely to respond to different disturbances so that we can help kind of manage which species are going to occupy that site over time. And again, we're doing this all to reach landowner objectives. So landowners let their foresters know what they're interested in managing for, and then the foresters or other natural resource professionals will use this shade tolerance and succession knowledge to make recommendations on what practices to implement. And this can help us have a much higher biodiversity. One of the things that can change over time is when you get fewer and fewer species, that biodiversity is going to go down. So by managing this appropriately, we can make sure that we have a good mixture of different species on that site for providing different habitats for both all the different flora and fauna that we find in our forest. So those are just some of the real reasons that we use this deep understanding of shade tolerance to help us. So I want to kind of go over a few of the common trees that we have here in Kentucky regarding their shade tolerance. I think it's important to note that this is not necessarily always static within trees, and we'll use white oak as an example. So white oak is one of the more shade tolerant of our oak trees, even though we group it in this intermediate category. So when it's young, it can be quite tolerant of shade, but that tolerance goes away as it ages. And we can have trees that can persist in a canopy with very low light canopy for a long time. They're never likely to be successful if they're released once these kind of trees get suppressed. But I did want to show you this flagpole right here. So this is a white oak flagpole that you're seeing on the right image, and it happens to be from our current Tree Farmer of the Year, the Mark and Mary Lee in Menifee County. And he found this white oak in his forest, and it had been overtopped. And then they cored the tree, and they found it was 90 years old. So this is, again, maybe around 6 inches or so in diameter at the bottom there. And it was a rather small overtop tree, but it was 90 years old. So this was a white oak that had lived for a long time and just hung out in the forest, but it really never was able to grow and be successful. So point being, this can change over time. So some of our more common shade tolerant tree species we have in Kentucky: American beech and sugar maple and hemlock, certainly some of the most shade tolerant species we have. But there are some others, shellbark hickory can have some shade tolerance as well. Dogwood can be tolerant, and red maple is one that can kind of change over time as well. So those trees that I've got asterisks on, they have some plasticity in their shade tolerance as at different stages of their life. And then many that we're interested here in Kentucky are shade intermediate species. And this really encompasses many of our oaks and hickories, which are our dominant tree species here in the state. And then we have a number of shade intolerant species that many of you are probably familiar with: our yellow poplar, which is our state tree of Kentucky, but black locust and white ash and others. So again, we try to group these trees in categories to help us kind of make decisions on how to manage for them. So there are some different techniques we can do when we were trying to promote different species that have different shade tolerances and targeted thinning. And many of these are basically the same practice, but it's which trees we're selecting by which trees we're targeting. So we can use this targeted thinning to, modify the light that's in that environment. And basically what we're trying to do is favor those shade and tolerant species in this setting to try to make sure that they have the room to grow. So we can get rid of trees that are really inferior or the wrong species composition to help us do that. And then we can create gaps. But when we're creating gaps to try to favor shade tolerant species, we want to do it with small gaps. So if these gaps get too big, they allow too much light in, and that will influence different species getting established. So we'll make these gaps rather small. It creates enough light on the forest floor to stimulate the shade tolerant species, but not enough to stimulate some of those other shade intolerant or shade intermediate species. Sometimes we may do understory plantings, and we may choose some very shade tolerant species with maple and others. But I would always recommend that can be a risky undertaking when you're planting seedlings into an established forest. Often it requires a lot of babying to help make sure that those trees get established. So wouldn't do this without working with a professional just to save you a lot of time and frustration. Keeping going, controlled burning's another way, and we can use this really for different species. It's just how we implement the controlled burn. Again, this is something you would want to work with a professional on, make sure you're doing it appropriately. And we always got to monitor and keep up with what's working and not, so we have to make adjustments as necessary. And this means that we have to get out there and we have to monitor what we've done and make those adjustments. Excuse me. There are some real benefits to promoting these shade tolerant species, right? And again, mainly it's from a biodiversity standpoint, because that biodiversity gives us greater forest resilience. As we have a variety of species there, they're ready to respond to different types of disturbance that may come down. And they can also provide some nice aesthetic value as you have a nice mix of different species and leaf colors and other things that some of these shade tolerants will often have. Um, it also creates a much more wildlife friendly environment. Wildlife really enjoys a wide variety of habitats, and these having these different species in there can help provide that as well. When we think about our shade intermediate, again, these are the ones we work often with here in Kentucky. We're trying to get basically a dappled light effect, if you will, in that forest floor. We don't want full sunlight, but we also don't want it too shaded. So somewhere in that medium area is about what we're looking for to try to help those species be successful. So we can start doing practices like a group selection. That's where we want to kind of create a bigger opening. Again, we want this opening to be big enough to favor certain species, but not the ones we're not targeting. So Dr. John Lotka here in our department has done some research along with others on this. And some of the things he looked at different opening sizes and what species were benefiting from that. So 50-foot openings really supported our shade tolerant species. Again, we're not getting enough sunlight to trigger some of these other species. 150 feet or so was about the sweet spot for many of our shade intermediate species, such as oaks. So if you're going to put an opening into a forest, when you want to target these intermediate species, that's what you're looking for. And then we found that once you get over about 250 feet, then you really start really favoring those shade intolerant species, and yellow poplar and other shade intolerant species really can take over and thrive in those settings. That's why we often use the shelter wood cutting. It's basically a series of cuts that we'll do over time to set that forest up to be successful growing oaks and hickories. Um, and again, we're just really manipulating the light in all of this. And so it's that deeper understanding that helps us. We can also use the edges, are great places to get some of our shade intermediates established. It can provide really great habitat. Certainly from a wildlife standpoint, those edges are really important. Again, with planting, it's something we can do, but I would strongly urge you to work with a professional when you're doing that. You don't want to waste your time and energy while you're doing that. So you'll want to choose native species, obviously. but make sure that you again, work with a professional. I don't want you all to be frustrated. You're planting oaks under a canopy and you're like, Billy, they didn't grow very well. But working with a forester, they can help make sure that happens. And, we can also use it to protect from competition by controlling this light. Right. So if we allow too much light on the site, then we know we're going to be fighting our shade intolerance like our yellow poplar. So we just want to be cognizant. Whatever we're doing, we're creating that medium amount of light for those intermediate species, and that way they're going to be most successful. Thinking about our shade intolerant species, again, these are trees that grow in kind of full sunlight. So we're going to create bigger gaps. So these openings need to be bigger to allow those species to be triggered and be responsive. Again, we can use thinning appropriately. Again, we're going to start removing some of our inferior trees. We can always use these thinnings to improve the overall health and vigor of the forest by getting rid of trees that are not successful or not doing well, maybe occupying growing space. We can get rid of those and free that up for others. But again, we want to make sure that we get the amount of enough light in to make sure that they're successful. Because if we don't get enough light in, these shade intolerance are not going to be there. Again, controlled burnings, a practice that we can use, but work with a professional to make sure you're doing it appropriately. Again, many of these approaches can be applied to different settings, but it's how we apply them that is so unique. Certainly sunny areas are places that shade intolerant species should be very successful. So if you have an open field or some other place you're trying to get started, work with a forester to identify appropriate species there. We do want to manage, obviously, any competing vegetation because if we don't let those trees get the amount of sunlight they need, they're not going to be successful. So anything that's overshadowing those trees would be a good candidate for removal. And this can be done in a wide variety of ways, right? We can use herbicides if necessary. We can mow. Whatever your forester recommends is what I would say. Work with them on that, managing that stand for you. And from a practical standpoint, understanding the shade tolerance of trees is really a valuable insight into managing our forest. So I've given you a couple resources. Laurie Thomas does our Trees of the Week here on From the Woods Today. And each of those, she talks about the various shade tolerances of those trees. There's also some good U.S. Forest Service publications that go over all of the various species that we have here in Kentucky and their shade tolerance as well. But most importantly, have a good understanding of what you want out of your forests, and that allows your foresters and natural resource professionals to work with you to implement practices that will help you. Again, I want you to realize that your natural resource professionals take all of this understanding and knowledge into account as they're making recommendations on what's to be done on your forest. And that, this understanding has been based on a lot of observation over time and a lot of research. I'm highlighting our oak shelter wood publication here, Dr. Jeff Stringer and others had put together for us. But this is a professional publication targeting really foresters, helping them understand how to implement this oak shelter wood, and which requires different light levels at different times in that forest to get those oaks established. So again, just know that your professionals have this knowledge and they're using it to make these decisions. And if you don't have a management plan right now, that's a starting point, because that's going to get you working with a professional. They're going to understand your objectives and they're going to help make appropriate recommendations for you. All right, so wrap up real quick. Shade tolerance is a critical concept that we understand, and it's the ideal that trees can grow, different tree species can grow in different light levels. We do know it influences both tree growth survival, as well as the composition and succession of our forests. And we can use this knowledge to make practices on the forest that will move it toward your objectives, and that's what your professionals do often. And if you all have any questions, I'd be happy to speak with you, but there's really no substitute for having a forester or other resource professional on your property working and with you on that land. So thank you all and good luck managing your forest. And as always, let us know if we can be any of assistance.
Awesome, Billy. Really love it.
All right, went a little long on you all. Sorry about
Okay.
that. Tried to wrap it up, but yeah. So a good concept. Just keep in mind your foresters know this. They're trained in it. We train them throughout their training here at UK to understand this concept. And again, it's a pretty critical concept when it comes to understanding our forests.
Right. Sounds like it. Sounds like it's a good thing that you had this to kind of go over this to let our woodland owners know that this is a critical thing that they need to be looking at.
Yeah, yeah, and again, I want you to understand that when foresters make recommendations, there's all these things that are going on in their head, right? Understanding the trees, how they respond to different practices is a big part of that, and certainly shade tolerance is a big part too.
Right. And just because you could have two different land tracts and they will tell you two different things. It doesn't,
Yeah,
it just
and they
depends.
could both be right.
Right. And it could just be, it depends, right? I know
It
you've
really
said that
does.
several times. Yes.
It does. It does. So,
Yeah.
but good.
All
Well,
right.
thank you all. Really appreciate y'all being with us today. It was a great show. Appreciate Dr. Larson as always. He does such a great job. But
So do you.
Fireflies. Thank you. And yeah, and I hope you all got something out of the shade tolerance presentation as well.
Definitely. And you can always go to fromthewoodstoday.com. I've already got some people emailing me that says, "Hey, how can I catch that Firefly show?" About a week, no later than a week, from thewoods.today.com. All of our shows will be on there and you can watch them and as much as you'd like. So until then, we will see you all next week. Take care.
Bye,
Bye.
everyone.
From the woods today. From the woods today.